I'm Kenneth Wong, Senior Editor for TE 24/7. In this episode, we are speaking to Jon Peddie from JPR. JPR is known for its research and cutting-edge analysis of many of the hardware that affects our design and engineering software industry. So, John, recently JPR published a report. Could you talk to me about this report and what the scope is and what it is about?
Sure. This is a report that is close to 10 years in the making. And I say that because we started this report in 2015 looking at AI processors for vision. And that's where AI kind of got its beginning, if you will. You will remember the very first LLMs, their test was find a cat. And it did it marvelously so. Well, that AI evolved into, thanks to Moore's law, into SoCs and kind of disappeared as a standalone item. Market stayed a little quiet, and then LLMs got better and better, and simultaneously, GPUs, made most famously by NVIDIA, also got better and better. And it was a marriage made in heaven. They, kind of coincided just at the right time, right place. The AI scientists, the people who were developing these LLM algorithms and so forth and training things, they were, doing their work, and then they said, "Oh my God, we've got more processing power. Now we can do this." And then the GPU people said, "Oh, we can give more processing power." And this thing just kept climbing up and climbing up to the point where we are today, and it's not a stopping point at all, is that you and I, and millions of others around the world like us, are using AI on a daily basis. It's just another but new tool that we can avail ourselves of. Well, then it spread, and it went from training to inferencing to vehicles to edge devices, which are PCs and smartphones and so forth, and all the way down to tiny little things that we call AI, IoT. And that's where we are. So it's mushrooming in applications. It's mushrooming in suppliers. We've identified, put your seatbelt on, 137 AI processor companies. And it's a mind-boggling number, and it's one that obviously can't be sustained. No market can sustain 100 and some suppliers. But right now, it's exciting as hell because all of these 137 companies are trying to do something different. And the thing they want to do most of all different is going to be different from NVIDIA.
How are these smaller companies challenging the big one? Are they challenging at all, or are
Yeah.
they finding different markets that the big guys are overlooking?
Well, a little bit of yes to everything you asked. They definitely are challenging the bigger companies, and that challenge is being met in one of two ways. Either A, the big company sees what the little company is doing and does it, bigger, better, faster, or B, they acquire the little company. We're averaging about 3.5 acquisitions per year for the last 4 years of startups that a bigger company saw and said, "Oh, let's just buy them. We can get that technology faster that way." And I'd say roughly 80% of those acquisitions have been successful, which is a high number. Typically, you have cultural mismatches and invested parties at the bigger company who squash things like that. And Intel has a terrible record of acquisitions for those kinds of reasons. The AI acquisitions that are being made of the smaller companies are really working very well. And NVIDIA gets credit for that too. They've done a good job on their acquisition trail.
How would you characterize these challengers? Are there something that they share in common, or are they just all over the map?
Any startup shares in common courageousness and ambition, and I'd say secondarily, creativity. There are many dozens of these startups who have really genuine novel ideas. And so we're in a really evolutionary period now. It's like when all the species in the world kind of exploded at one time. and try to find food and try to find, a way to evolve and survive and carry on. One of the most interesting ones, I don't know if it's going to work or not, but it's really interesting, is an analog mimic of our neuron structure. And so we have a thing called we have neuromorphic and CIM, where the processing is being done in the memory and or being done in analog form. And that's it. That's a test. This is a mutant test, an evolution. Is this going to work? Is this going to really deliver something? Is this going to give us a power savings and a performance increase? And is this going to deliver the promise? We won't know. We won't know for a few more years. The other is there's still big demand on vision, even though a lot of the stuff has been absorbed. And vision isn't just in the visible range. It also includes the extensions of it into IR and UV and so forth, and LiDAR and those natures. And they all have the same problems. They have to differentiate things that are in front of them or near them. And that's a hard problem. AI real-time processing in a car or a robot is enormous, just enormous. And that's going to be a black hole for a very long time. There's going to be a lot of energy and a lot of technology poured into that problem to try and get to the point where automobiles, trucks, boats, airplanes, and robots move fluidly and naturally and don't bump into us and knock us over, but at the same time can gently pick us up if we fell over and take us to the hospital or put us in our chair and give us our pills, right? Or at the very other end of the extreme in the AI IoT spectrum are the AI companions. And these are little things about the size of a mouse or maybe bigger, shaped like a cat, purrs like a cat, responds to you if you touch it, runs around, does things. And, if you're a lonely person or a kid, that's a beautiful little companion. And it's got a little AI machine running into it, but it's not connected to the cloud. It's all independent. That's why it's IoT. That's the spectrum of stuff we're talking about. And big, big dollars are being poured into it. There's like, I don't know, I think it's 20 or 30 billion right now has been invested in these startups. 20 or 30 billion has been invested in these startups. That's in addition to the 120 billion that the publicly held existing companies are spending every year, not a one-time pop to get a startup, but they're spending it every year. You look at NVIDIA, Intel, AMD, Qualcomm's R&D budget, and today a big hunk of that R&D budget is going towards AI. And just add it up, right? You don't have to be a Wall Street analyst to do that. And you say, holy cow, that's a lot of money. You pour that much money into something, something's got to happen.
When you are talking about investment, the recent news is that NVIDIA and Intel, I've always thought of them as arch enemy, especially when it comes to CPU market. But NVIDIA has recently invested 5 billion in Intel. So what are your thoughts on that? And what can we expect would happen to each of these companies?
Well, NVIDIA has never really been a competitor to Intel, and a couple of small occasions they have been on competitors. Generally, they haven't. They've generally been complementary in that Intel does the CPU and NVIDIA does the GPU. And until Intel started building a GPU, which they haven't done very well, but they're building it. And until then, did they become a real direct competitor to NVIDIA. But even that, it was a mismatch because Intel's GPU doesn't have any near the performance that NVIDIA's does. But NVIDIA's bigger competitor, more direct competitor, is AMD. And NVIDIA has built rack mount units since, trying to think how long ago, quite some time. They started out building this thing called Grid, which they've now turned into GeForce Now, which is a cloud-based server to stream games to you. Anyway, they started building this thing sometime years ago, and the central processor in it was an AMD processor. So it'd be an AMD processor and then 4 or 8 NVIDIA graphics boards. And that was okay, and they got along all right. And a lot of the people at NVIDIA used to be at AMD. Jensen Huang worked for AMD a long, long time ago. So, that cross-fertilization is something that's been going on for decades. But anytime NVIDIA bought a CPU from AMD, that put money into AMD's R&D budget that would come back against NVIDIA later. So it wasn't really a, a totally comfortable situation, kind of a necessity more than let's say, a virtuous relationship. Intel didn't have that characterization with NVIDIA. And so NVIDIA's investment into Intel does a couple of things. Number one, it uh, allows Intel to pull back on its GPU business, and they've been doing that anyway, and just concentrating on integrated graphics and not really pushing the discrete graphic stuff because it's hard work. It really is hard work. And number two, it gives NVIDIA a special chair, if you will, at the negotiation table with Intel for CPUs, x86 CPUs. So NVIDIA already has an ARM CPU, and that'll get them so far, but it's not going to get them everywhere. And so having a strong partner who makes an x86 processor, that kind of like fills all the other holes. So it's a very logical, a very smart move. It's a win-win situation. Intel needs the money. Intel will benefit from NVIDIA's GPU technology if they tap into it in some way. NVIDIA has a solid partner for an x86 processor for their server chassis, a respected name. The old joke about nobody ever got fired for buying Intel. Well, nobody ever got fired for buying NVIDIA either. And so now you got the two of these guys coming together. Someone walks into your office, you're a data center manager, and they say, "Hey, I'm from Intel and I'm from NVIDIA, and we're here to help you." What are you going to say? Thank you. Can I get you some coffee?
The report specifically deals with the AI processor market, but one of the trickle-down effects we're interested in for our readers is how this explosion of AI processors are going to have an effect on simulation and design software. What do you foresee?
Well, design software uh, today, not always, but today, design software is a big user of LLMs. It's more and more built into design software, especially simulations, because in simulations you constantly are running what if this, what if that, right? And that, I mean, that's you spend half your time in FEA, for example, doing what if, crashing things and blowing them up and twisting them and trying to find out where and why they're going to break. And if you just do that on a CPU, which is where it has been up until almost now, it takes time. CPUs aren't particularly good at that. And I mean, the CPU guys will tell me I'm working out my butt and don't know what I'm saying, but I've run a few simulation programs. But the problem is, how do I wrestle those thousands of parallel processors into my existing code that I've been selling for the last 30 years based on a CPU? And that's the hard part, and that's why it's not moving as fast as you'd like to see it. And it comes in drips and drops. Like this little sub process will suddenly be working on a GPU, and then this one will be working on a GPU, and that one, and so forth. And the GPU will eventually take over. It won't be that much longer, and along with it will become the LLM interface. So, as a simulation or a design engineer, your tasks now change from the way you used to do things to the way you're going to have to do them now, which is you're going to have to learn to intelligently speak to your computer. And whether you do it on a keyboard or with a microphone, doesn't matter. You're going to have to learn to speak its language. And the deceptive part about that is that the confusing part is you think it speaks English because it talks to you in English and you have a conversation back and forth. But it's a very restricted English or whatever language you're using, but I'll use English as an example. But anyway, it's restricted and it's going to teach you how to talk to it. And the way you learn is because you're not getting the answers you want. So you say, uh, draw a cube, 3 inches by 3 inches by 3 inches, color each side a different color, and put an antenna on the top. God knows what you'll get. And this is a threat because there are a normal distribution in any society, and a society of engineers has a normal distribution. There's going to be a group of people who just don't want to learn or can't learn, and they're going to be the casualties. And they're the ones going to be making all the noise on social media about how bad AI is and how it stole my job. And so it never stole your job. You gave your job up. You just didn't do your homework. And that's where we are now. We've got to do our homework. I'm doing my homework every day, learning how to talk to this damn machine.
When this report came out, you told me that there are two new acronyms that I should be learning if I want to sound smarter when talking about this. And one is YANK, Y-A-N-K. Another one is YAP, Y-A-A-P. Tell us what
Yeah.
they mean.
Well, well, Yank is NVIDIA doesn't like that term, but I use it anyway. Yank is yet another NVIDIA killer. And the first wave of AI processors that came out in the 1718s, 2017, 2018, actually a little bit later, 22, I think, and 23, started out that they were going to dethrone NVIDIA with their GPU. And most of these, by the way, were Chinese. They had the ambition that they were going to knock NVIDIA over. Yeah, good luck with that. And so they were going to be NVIDIA killers. And there were a few others in the United States that had a similar idea, but not in a direct GPU competition, but a slightly different architecture. But nonetheless, knock NVIDIA out of the way. And we here at JPR laugh at that. That's the term yank. Yeah, you can develop your own connotations of what that means. But
Y-A-A-P? Yup.
YAP
What is
is
that?
more acceptable than NVIDIA and a lot of other people too. And that's yet another AI processor. And when you've
Okay.
got 137 of them out there, that's a totally legitimate thing to say. Oh, yet another IOP processor. Oh boy.
Well, John, thank you very much for spending time and sharing your insight. I appreciate it.
Happy to, I love this stuff. So, anytime you want to talk about it, just pick up the phone. Can I give my email address?
Of course, by all means, if you feel comfortable, go ahead.
Yeah, sure. It's John, Jon, easy, at Jon Peddie, JONPEDDIE.com. I answer all emails. I try to do it within 24 hours, but if you have questions, I'd be happy to answer them.
In the text version of this article summary, I'll go ahead and make sure that your email is in there for people to see.
Thank you.
Um, Welcome. Until next time, I'm Kenneth Wong, Senior Editor for DE 24/7. And if you'd like to hear more engineering news, go to Digital Engineering 24/7. That's digitalengineering247.com. With that, I'm out.